This meeting is being recorded.
In Chapter 13, Problem 1, we are asked to give the IUPAC name for each of these following compounds. So let's take a look at compound A here, and we see the oxygen atom has two groups attached to it. One group has two carbon atoms, and then our other group here has three carbon atoms. So we name the parent after the larger group, so the parent will be propane. And the smaller group with the oxygen atom is treated as an ethoxy substituent. So that's what we have over here. And then the parent is a propane. So if we put all of this together on the carbon 2, we have our ethoxy substituent. So this would be named as 2-ethoxy propane. Let's take a look at compound B here. And again, we have an oxygen atom with two groups attached to it. One of the groups has three carbons. So we have 1, 2, 3 over here. The other side, we have 2. So we know the parent is named after the larger group. So the parent is propane. And the smaller group with the oxygen atom is once again called an ethoxy substituent here. And the locant for this would be on carbon 1, actually, because we should name this going this way. So we have our lower numbering system. So now when we assemble this name, we also have to give configuration for the substituent. So let's take a look here. So we have 1, 2, 3 as our priorities go, and we know that we also have hydrogen that is on a dash. So if we looked at this, 1, 2, 3, this will be an S configuration. So now we need to add our chloro substituent. So that's on carbon 2. We need to add our configuration and our ethoxy substituent. So let's put all this together. And for compound B, we're going to have S2-chloro. And then on carbon 1, we have that ethoxy substituent. And then our parent was propane. All right, so let's take a look at compound C here. And the oxygen atom, once again, has two groups attached to it. The parent will be named after our larger group. So our parent will be a benzene, as we see here. That's larger than this 2-carbon chain over here. So the smaller group, this would be, again, an ethoxy substituent with the oxygen and the 2 carbons. The locant would be on carbon 1 here for that ethoxy substituent. And that would then be an 1-ethoxybenzene. And now we have to name the position of these 2 chloro groups. So we would have carbon 2, 3, and 4. So if we put all this together, we're going to have 2, 4. Then we have dichloro. 1 for that locant for the ethoxy. And then the parent was benzene. All right, and let's take a look at D here. So now we have 2 chiral centers. So we're going to have at carbon 1 and carbon 2 here, we're going to have 2 chiral centers to name at the end here. So 2 configurations rather. So the parent here is going to be cyclohexanol. This here is a 2-carbon substituent, right? This ethoxy group here. And that will be on carbon 2 because our parent is named as an alcohol. So we assume that this is on carbon 1. And then we need to assign the configuration. So let's take a look here. So we have 1, 2, 3 as our priority on carbon 1. So we're going to see that that is an R configuration. And then let's look at 2 here. So we have 1, 2, 3. So we see that this configuration, we would think it would be S, but our lowest priority needs to be on a dash, and we see that our highest priority is. So we would invert or change this from R to S at our number 2 carbon. So let's put everything together here. So we've decided that our configuration at carbon 1 is R. The configuration at carbon 2, we've inverted that to be an S configuration. Oh, I'm sorry. Or rather, what did we do here? We actually inverted this the other way. I apologize. So we would say that we would think that it is an S configuration because it's going counterclockwise, but we actually change it to R. So they're both R, 1R, 2R. And then we have our 2-ethoxy cyclohexanol. All right. And then last but not least, we have to name our parent here as cyclohexene. And then we have this ethoxy substituent once again. This will be on carbon 1. So we would name this 1-ethoxy cyclohexene.